screen?
Yes. Yes. Yes.
Good. So we are looking at the term used in reflection of light. And so far we have looked at how many of them? We have looked at 7 of them. 7, right?
Yes.
So you can see from our diagram there. So we are still going to use the same diagram, that ray diagram. So let's look at the 8th term, which is angle of deviation. Angle of what? Deviation. Just to give you a perspective, let me draw it again here so that you can see. Okay? Members, are we together?
Yes.
I said if this is our reflecting surface, M prime, then there's a ray of light incident on the reflecting surface at the point of incidence. At that point of incidence, it must be perpendicular. It must be what? Perpendicular. Then is reflected. Is reflected back. Is reflected back or bounce back. So don't forget to put the arrows. Now, assuming what we do that, assuming there was no this reflecting surface, which means this light rays will continue moving in a straight what? Will continue moving in a straight what, members? Will continue moving in a straight line. So which means I will produce this line like this, like that. So we say this angle here, this is what we call angle of incidence. Then this angle here is called angle of reflection. Then this angle here is called glancing. This is G, glancing angle. Also, this one is called glancing angle. So we said if this is point A, or B, this is N, I can call this one point, I can call this one C. I can call that one what? C. So we are saying that the angle from here up to this point, up to that point, that angle is what we call angle of deviation. Is what we call angle of what? Deviation. D is what we call angle of what? Deviation. So this one is glancing angle. This one is also glancing angle. And that property is it? Which property have we used there? Alternating angles. That property is alternating angles. Are we together, members? Members, are we together?
Yes.
Good. Good. So now let's define glancing angle. What is glancing? I mean, angle of deviation. Let's define angle of deviation. Let's define angle of deviation. Let's define angle of deviation. So we are going to define angle of deviation as number 8, angle of deviation. Angle of deviation, D. Angle of deviation, D. We said this is the angle, this is the angle, this is the angle, this is the angle between, this is the angle between the reflected ray, between the reflected ray, between the reflected ray, between the reflected ray and the direction, and the direction of, and direction of, and direction of the incident, of the incident ray, of the incident ray, and the direction the incident ray would take if there was no reflecting surface, if there was no reflecting surface at a point of incidence. At a point of incidence. At a point of what? Incidence. Are we together, members?
Yes.
So angle of deviation is the angle you can see from here. You can see it from here, from our diagram here. So the angle from here, from the reflected ray out to the direction that the light ray would take if there was no reflecting surface, which is it? AC. AC. We are saying that AC, this direction is dotted, is imaginary. I'm using dotted line because it's imaginary. We assume because if there was no reflecting surface, this incident ray will continue moving in a straight line. Will continue moving in a straight what? Line. But because of this reflecting surface, this light will be reflected along or B. So the angle between the reflected ray and the direction the light would have taken if there was no reflecting surface at the point of incident, that angle is what we call the angle of deviation. That angle is what we call angle of what? Deviation. Are we together, members? Members, are we together?
Yes.
Yes. So that is it. That is what we call angle of deviation. That is angle of deviation. Good. Now, let's write this. Note. Experiments have proven that or as proved, should be as proof that the angle has proven that the angle of deviation is twice the glancing angle. Is twice the glancing what? Angle. In bracket, D is equals to 2 G. D equals to 2 G. Why are we saying that? Why are we saying that? Let's check it out. Let's check that one out. Let's check it out. Or let's prove it. Now I'm using, our diagram is there. Members, are you seeing that? Members, are we seeing that?
Yes.
Now we want to prove that because we are saying angle of deviation is twice the glancing angle. Because members, if you look at this one, let's look at this one. We said because glancing angle. So from geometry, so we'll say from our geometry, we can see clearly glancing angle, which is the angle B O C. Angle B or what? C is equals to, is going to be the same as angle B O M prime. Members, have you seen that? Plus angle M prime O C. Members, have you seen that? To get all of this angle is the same as adding this angle B O M prime, then M prime O C. But when you look at this angle, what can you say about this angle, members? What can you say about this angle? What can you say about this? What is that angle? Look at it critically. What is that angle, members? This one here. What is that angle? I sing this one. I sing that. Huh? Members, I sing that. Which property is that? These two angles, they are what? They are vertically opposite. They are vertically what? They are vertically opposite.
Opposite.
So which means we said opposite angles are always what? Equal, no, sir?
Yes.
So which means this angle is also what? That angle is also G. So it implies now angle BOC, which is our glancing angle D, okay, equals to, which is also G plus what? G plus what? G plus G. Therefore, our D is equals to 2 to what? Members, have you seen where it's coming from? Members, have you seen it?
Yes.
Yes. That's how we prove that. So we say, therefore, glancing angle deviation is equals to twice. Take note of that. Take note of that. Where D is the angle of deviation. D is the angle of deviation. Then G is the glancing. Is the glancing what? Is the glancing? Is the glancing angle. Are you together, members?
Yes.
Yes. If that is true, and we know what glancing angle is, who can remind us what is a glancing angle? Who can remind us very fast? What is a glancing angle? Yes,
The glancing angle is the angle. The glancing angle is the angle between the incident ray and the reflecting surface at the point of incidence.
Very good. That is one. There's also another one. Who can define us using reflected ray? Linear Azul's incident ray. Who can use reflected ray? Yes? Someone can say glancing angle is the angle between the reflected what? Is the angle between the reflected ray and the what? And the reflecting surface at the point of incidence. Are we together, members?
Yes.
Yes. So those are the terms. Now, before we go and we look at laws of reflection of light, let's do some calculations on this. Calculations. Question number 1 is not on the screen. I'm just going to read for you, okay? Okay?
Yes.
They're saying a light ray strikes a reflecting surface, at a glancing angle of 45 degrees. Find the angle of reflection. Find the angle of what? Of reflection. Find the angle of reflection. Are you together, members? Members, are we together on that?
Yes.
Yes, that's the question. That's saying a light ray strikes a reflecting surface. Strike a reflecting surface. Sorry, should be reflecting surface. Strike reflecting surface at a glancing angle 45 degrees. Find the angle of reflection. So the first thing you do here is start by sketching a ray diagram. You start by sketching the ray what? The ray diagram. So we first draw ray what? Ray what? Ray diagram. So let's draw our ray diagram there. We have that. This is our reflecting surface. To show that it's a reflecting surface, we use that line. So we have the incident ray there. Then this is our normal. Then this is our normal. Then that's the reflected ray. So we have the incident ray there. This is the reflected. So now when you look at the question, I've said the glancing angle is 45 degrees. So where are we going to put that angle? Where are we going to put that angle? Members, where are we going to put that angle? Patricia, there's a lot of noise in your background, please. Members, where are we going to put that 45 degrees? Where are we going to put it? Here or here? Where are we going to put the glancing angle, which they have given us? Please, let's contribute, please. Vanita. Yes, Cynthia. Members, where are we going to put that angle, 45 degrees? Because I've said a ray of light strikes a reflection surface at a glancing angle, 45 degrees. So where are we going to put? Now, which means for you to answer this, you must know what is a glancing angle. We said glancing angle is the angle between the incident ray and the reflecting surface at a point of incident, which is this one, which is here. So this angle is 45 degrees. This is angle of incidence, I. This is angle of reflection, R. But we have said this one is also, this angle is also what? 45 degrees, because that angle is still glancing angle, is our glancing angle. So which means if you want to find the angle of reflection will be, so it will be R plus 45 degrees. Remember, this one is a normal line. This is a normal line. It's a normal, which means the angle to form is what? 90 degrees. So that angle is 90 degrees. So when you add R plus 45 must give us 90 degrees. So which means our R will be equals to 90 degrees minus 45 degrees. So therefore, our R is equals to 45 what? Degrees. As simple as, members, as simple as what? As simple as that. Are we together?
Yes.
Yes. That is question 1. Question number 2. Question number 2. Question number 2. The question is saying find the angle. Find the angle between the incident ray. Find the angle between the incident ray and find the angle between the incident ray and reflected ray for a ray of light that strikes the reflecting surface, at a glancing angle of 35 degrees. Are we together, members?
Yes.
Good. So let's answer that. I said, any question here in light, the most important step is to draw a ray diagram. Because it's from the ray diagram where you can analyze. The diagram very well. So let's sketch ours here. This is the reflecting surface. This is our reflecting surface. A ray of light is incident. So this is our normal, which must be at the point of incidence, members. It must be at the point of incidence. Make sure that when you are doing, do it very well. Take note of that. This one, they must be at a common point there. So this one is that one is that. So members, what have they said? What have they said from the question? What have they said? They've said the what? Angle of what? Glancing angle is what? Is 35. So which means this angle is what? This angle is 35 degrees. Members, let's contribute, please. Let's contribute. Let's not keep quiet. Let's discuss. Let's discuss. The angle is 35 degrees. So which means this angle is also what? 35.
35.
We know that this angle is called what? Angle of what? Incidence. This angle is also what? Angle of reflection. Now, when you look at the question very well, what do they want? They want us to find the angle between the incident ray and the reflected ray. So they want us to find all of this angle, all of this one. I think that this is the angle they want us to find. Incident ray and reflected what? Ray. Members, have you seen that? Yeah. So let's say, let's call that angle X. Let's call that angle what? X.
Angle X.
But before we get even angle X, so you can say it implies that angle X is equals to what, members? Is this equals to angle I plus angle what?
R.
R. But do we know I and R? Do we know I and R?
No.
So we have first to get them. We have first to get them, not so? Let me create a space there. But we know that to get this angle, we know that this line, if you look at this one, this is a normal line. This is a normal. This line is perpendicular, which means this angle is also 45. This angle is also 45.
45.
Have you seen that?
Yes.
So, which means I plus 35 degrees is equals to what? 90 degrees.
90 degrees.
So which means our I will be equals to 90 degrees minus 35 degrees. So what is our I? What is I?
55 degrees.
Is 55. Is 55 degrees. Also, R plus 35 degrees must be equals to what? 90
degrees.
So which means our R is also equals to 90 degrees minus 35 degrees. So our R is equals to what? Also what? 55. What have you discovered? What have you discovered, members? I is equals to?
R.
Which means for reflecting surface, angle of incidence is equals to angle of what? Reflection. Good. So, but that's, we are not looking for that. We are looking for X. So which means our X, which is equals to I plus what? Plus R. X is equals to 55 plus 50 what? 55. So which means X is equals to what? What do we get?
110.
110 degrees. Is 110 what? Degrees. Have you seen that, members?
Yes.
Alternatively, what someone can decide to do, alternatively, members, when you look at our diagram here, we are looking at this angle X, which means I can say this is angle properties in a straight line, using angle properties in a straight what?
Straight line.
Which means I can say 35 degrees plus X plus 35 must give me what?
180.
So angle property in a straight what? In a straight line. So we can say 35 degrees plus what? Plus X plus 35 degrees must give us 180 what? 180 degrees. So which means you find out we shall have, it implies now we shall have X plus what? 30 plus 35 plus 35 we get 70 equals to 180 degrees. So which means our X is equals to 180 degrees minus 70 what? Degrees. So therefore, our x is what? 100 and
110.
110. Have you seen that?
Yes.
Uh-huh. Good, good. Number 3. Let's look at question number 3. Okay?
Yes.
Mhm. This question is very unique. Let's write it very well. Let's write it very what? Very well. So they're saying array of light from a bird makes an angle of 30 degrees with a plane reflector and a ray from the barrel of a gun of a what? A gun makes an angle of 60 degrees to the same what? To the same reflector. To the same what? Reflector. At the same point. At the same point of incidence. At the same point of what? At the same point of incidence M. They've named it M. As shown in the figure below. Full stop. So let's draw the figure. Let's draw it. So this is our reflecting surface. This is the reflecting surface. Members, let's array. We have 10 minutes only remaining. We have 2 minutes only remaining. We have 10 minutes remaining. So the angle is there. So that is from the bird. Then there's also another one from the gun. There's another one from the gun. It's like that. So this angle is 30 degrees. Then this angle is 60 what?
60 degrees.
60 degrees. So this is the point of incident M. That's the point of incident M. So this is our normal. That is our what? Normal. So this is the incident ray. This is also what? All are incident rays. All are incidents, okay? This one is from the where? This is from the what? The bird. Then this is from the gun barrel. Okay?
Yes.
Now, what do they want us to do? The question is find the angle through which the reflector must be rotated about point M such that the ray from the barrel from the barrel of the gun falls on the bad. Falls on the what? On the bad. Members, are we together on that?
Yes.
Yes. So now when you look at this question is very unique. It's very what? Unique in the sense that we have 2 points. We have 2 points, 2 sources of light. One from the bad, then one from the what? From the gun. Now, the one from the bad makes an angle of 30 degrees with the reflecting surface, which means this angle become our glancing angle. So our glancing angle is what? 30 degrees from the bad. Then from the gun, the glancing angle is what? Is 60 degrees. Now, they want us to find an angle through which the reflector should be what? Rotated about point M such that what? The ray from the barrel of the gun falls on the what? So which means our target is the what? Is the bad. So now, when you look at these angles, we say that for you to make sure that the angle must be the same. The angle must be the what? Must be the same. So which mean if I'm to rotate, I must rotate it through a given angle, not so?
Yes.
So let's draw it here. Let's look at solution. Let me redraw it here so that we can analyze it well. I'm repeating mine. So this angle was given to be 30. Then this one. So this angle is what? 30. Then this angle is what? 60. So this is the bad. Then this is the what? The gun. Now they want us to rotate the mirror. They want us to rotate the what? The reflector in such a way that now, members, should we rotate it if this is the reflector, not so? Should I rotate it like this or like this so that they can strike the bad? Should I rotate it like this or like that? How should I rotate it? You rotate it like this, not so?
Yes.
We should rotate the mirror like this. So let's say, let me draw it there. So this is the new position of the reflector. This is the new position of the what? Of the reflector. So let's say this is M. Now this one become M what? M prime. So I've rotated it through which angle? So the angle of rotation is now this one. The angle of rotation is this one. Let's call it that angle what? Theta. Not so? This angle is also what? Is theta, because they are vertically opposite. Vertically what? Opposite. Have you seen that?
Yes.
Now, members, when I rotate it like this, you can see that, which means the angle, the glancing angle has reduced, which means this angle will reduce by what? By theta. Not so? Not so? While this one will increase by what? By theta. Have you seen it?
Yes.
So now we said for the bullets, for the what? For the bullet to eat the what? To eat the what?
The bad.
The bad. For the bullet to eat the bad, comma. The glancing angle. The glancing what? The glancing angle must be the what? Must be the what? Members, must be the what?
Must be the same.
Must be the same. So now what is our new glancing angle? Our new glancing angle is now what? For this one, for the bad, what is the new glancing angle? Is this one also? I think that.
Yeah.
Which is what?
Yes.
Which is 30 degrees plus what? Plus
30
plus theta. Then
theta.
our new glancing angle for the gun is what? Is this one. I think that.
Yes.
Which is what? Which is 60 minus what?
60
Minus
theta.
minus theta. Yet we are saying that they must be the same. They must be the what? The same.
The same.
So which means it implies that 30 degrees plus theta must be equals to 60 degrees minus what?
Minus theta.
Now, what are we looking for? We are looking for theta, not so.
Yes.
We said
Yes.
where theta is the what? Is the angle of what? Is the angle of what?
Rotation.
Is the angle of rotation. So now, if that is true, which means if you collect, we shall have 30 degrees plus theta equals to 60 degrees minus what? Minus theta. So let's collect our like terms. So which means we shall have theta plus what? Plus theta, not so?
Plus theta.
Equals to 60 degrees minus what?
30 degrees.
Minus 30 degrees. This one is giving us what? 2 what? 2 thetas, no sir?
Theta.
Equals to what?
30 degrees.
So we divide all through by 2 by 2. So therefore our theta is what? What is our theta?
15.
15 degrees. Have you seen that?
Yes.
So which means the reflector must be rotated through angle of what? Through angle of 15 degrees. So as the bullets from the gun can eat the what? The bird. As simple as what? That you can even prove it here. 30 plus 15, what do we get? Is it not 45? It's 45, not so?
Yes.
60 minus 15, is it not 45?
Yes.
Yes. Yes. So that is it. Are we together, members?
Yes.
Yes.
Yes. So we have less than a minute. We have less than 1 minute. So when we come back, I will give more example and then we proceed. Okay?
Yes.
So far, is there any question before we go for the break? Any question?
No.
I'm clear, not so?